In the one sample proportion test, there's going to be 5 steps just like we did earlier, except now in step 3 we have a new test statistic. Z is equal to p hat minus p over the square root of p times the quantity 1 minus p over n, where p hat is equal to x over n, and remember x represents the number of success, and n is the sample size. We also have to check 2 conditions. We need to make sure np times the quantity 1 minus p is greater than or equal to 10, and that the sample size is less than 5% of the population size. In the second condition, I just have to write a sentence that says we can assume the sample size is less than 5% of the population size. Note that P is given in the null hypothesis and assumed to be true until evidence proves otherwise. This is similar to the judicial system. You're assumed innocent until proven otherwise. Example 1. You believe that 90% of the population would continue to work even if they inherit sufficient wealth to live comfortably without working. A list of 10,000 people who recently inherited more than $400,000 is obtained, and 350 people are selected at random from the list. Out of the 350 selected, 308 indicated that they are still working. At alpha equals 0.05, is this sufficient evidence to doubt your claim? We'll start by checking the conditions. We always have to check the conditions for a one sample proportion test before we start the problem. Condition 1, we need to check, make sure that NP times the quantity 1 minus P is at least 10. So let's try that out. We know N is the sample size. Looking at the problem, we know that we selected 350 people. So N is 350. P is the proportion of those in the population that believe they would continue to work. And in this case, we have 90%. So we're going to put P as 0.9 for 90%. So let's check the condition. N is 350, I'll plug in 350 for N. P, the population proportion, is 0.9 times the quantity 1 minus 0.9. And this number is going to be 31.5, and that's clearly at least 10, so condition 1 is met. Condition 2, I just have to write a sentence. We can assume the sample size is less than 5% of the population size. The population size is at least, and we're going to take the sample size that we had and multiply that number by 20. So this results in 7,000. So we're going to say we can assume the sample size is less than 5% of the population size. The population size is at least 7,000. And condition 1, condition 2 are met. So let's start the problem. We're making a claim about a population proportion. So the claim is P equals 0.90. We're making the claim that the proportion is 90%. We do not use the symbol mu because this is not a mean that we're looking at here. We're looking at a proportion that's related to the population. The complement is the opposite of this, though the proportion is P is not equal to 0.90. In step 1, I have to decide which one's the null hypothesis and which one's the alternative hypothesis. The null hypothesis is the one with the equal sign, so p is equal to 0.90, and the alternative hypothesis is p is not equal to 0.90. If you look at the alternative hypothesis, we notice that this is the not equal symbol. So this is a two-tailed test. I'm going to reject the null hypothesis if it's too low, or reject the null hypothesis if it's too high. So this is a two-tailed test, and that reminds me I need to double the p-value. Double the p-value since I'm doing this by hand. There's a two-tailed test, so we have to double the p-value. Step 2, we're going to state alpha. Alpha is 0.05. Step 3, for a one-sample proportion test, we have the test statistic z equals p hat minus p over the square root of p times the quantity 1 minus p over n. P hat is equal to x over n, the number of successes. In this case, we have 308 successes divided by a total of 350. P, we are given that the claim is equal to 90%, so P equals 0.9. So we can plug in all the values now into our test statistic. Z is equal to 308 over 350 minus 0.9. Divide the whole thing by the square root of 0.9 times the quantity 1 minus 0.9 over the sample size, which is 350. Now a good tip to use if you're struggling with the calculator is put parentheses for the numerator. You can do the top separately if you like, and then do the radical on the bottom separately. That would be easier to input in the calculator. And once you do the output, you get 1.25 for the test statistic. Z equals negative 1.25. In step 4, we're going to find the p-value. Now recall this was a two-tailed test, so we're going to reject it if it's too low or too high. And I need to find this area and double it for the p-value. In step 3, we know that the test statistic was negative 1.25. So the area I'm looking for is the area to the left of negative 1.25. But remember, we have to double this. It was a two-tailed test. So we're going to double this by putting a 2 in front of our probability. So this is equal to 2 times, using my z table, I get the area to the left is 0.1056. And we're going to double this, and that results in 0.2112. This area on the left is 0.1056, and since there's two of them, we're going to double it, and that's how we get this number, 0.2112. Step 5, we're going to state our conclusion. I always ask, is the p-value less than alpha? Our p-value is 0.2112. And is that less than alpha, which is 0.05? No, the p-value is not less than alpha. So I'm going to say we do not reject the null hypothesis. There is not enough evidence to conclude. And remember, our conclusion is always in terms of HA, HA, was P was not equal to 0.90. So we are going to say we do not reject the null hypothesis. There is not enough evidence to conclude the proportion of those that would continue to work is not equal to 90%. In 1997, 46% of Americans said they did not trust the media when it comes to reporting the news fully, accurately, and fairly. In a 2007 poll of 1,010 adults nationwide, 525 stated they did not trust the media. At the alpha equals 0.05 level of significance, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully and accurately has increased since 1997? We are going to start the problem by looking at our conditions. Condition 1, we need to make sure that NP times 1 minus P is at least 10. N is the sample size. I have a sample of 1,010 adults. And P is the population proportion, and we're assuming the population proportion is 0.46. Now we'll check if the condition is met. We'll plug in the value 1010 times 0.46 times the quantity 1 minus 0.46 equals 250.8, and that's clearly greater than or equal to 10. So the first condition is met. Condition 2, we're just going to write a sentence again. We can assume the population size is at least, I'm going to take the sample size 1010 and multiply by 20, and that will give us 20,200. So we're going to say in condition 2, we can assume the population size is at least 20,200. And this means the sample size is less than 5% of the population size. Since all of the conditions are met, we're going to look at the claim and complement for this problem. The claim is that the proportion of adults who trust the media has increased since 1997. So we're claiming that proportion P is greater than what? Well, since 1997, so it was greater than 0.46 or 46%. The complement would be the opposite, so the proportion would be less than or equal to 0.46. Now we can start step 1. The null hypothesis is always the one with the equal sign, so P is less than or equal to 0.46. And the alternative hypothesis is the one without the equal sign, P is greater than 0.46. Now again, on your homework, they're always going to use an equal sign when they're looking at the null hypothesis. On StatCrunch, they're always going to use an equal sign. But when we're doing it by hand, I like to use these symbols so that we can clearly see their complements of each other. But be aware on homework, they'll always use an equal sign. Step 2, state alpha. Alpha in this problem is 0.05. Step 3, we're going to use our test statistic, z equals p hat minus p over the square root of p times the quantity 1 minus p over the sample size n. P hat is equal to x over n. Let's look for the number of successes. Here we found 525 successes out of a sample of 1010. And P we know in the problem was 46%, so we'll say that's 0.46. Let's plug in the values into the formula. P hat is 525 over 1010 minus 0.46 divided by the square root of the sample or the population proportion, which is 0.46 times 1 minus 0.46, and we'll divide that by the sample size 1010. Again, make sure you put parentheses for the numerator, and then you can do the radical next. This gives us a value of 0.0598 for the numerator if I'm doing this separately. And the denominator should give us around 0.0157, and that reduces to 3.81. So you could do it separately by doing the numerator first and then the denominator, then calculating the value. Or you could just enter the whole thing in one try and get out the z-score of 3.81. Step 4. We are going to find the p-value. Now, if I look at our alternative hypothesis, we said that the proportion was greater than 0.46. That was the alternative hypothesis. This is going to be a one-tailed test. We're going to reject it if it's too high above 0.46. So we do not need to double the p-value. The p-value is equal to the area to the right of our test statistic from step 3 of 3.81. Use your z-table to find the area to the right. Using the z-table, I know that this area is 0.9998. But remember, since it's area to the right, I have to subtract from 1. And our probability, or our p-value, is now 0.0002. Step 5, we're going to state our conclusion. Ask yourself, is the p-value less than alpha? Is 0.0002 less than alpha, which is 0.05? Yes, it is. We do reject the null hypothesis. Since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude. And remember, our conclusion is always in terms of HA. HA was the proportion was greater than 0.46. So we can say we do reject the null hypothesis. There is enough evidence to conclude the proportion of adults that do not trust the media is greater than 46%, or 0.46.